Hello, everyone. The subject of my presentation is the importance of IGS products and standards for the processing of a regional GNSS network. In this case is SIRGAS, which means Geodetic Reference System for the Americas. So the title is Processing a Regional GNSS Reference Network in the Framework of the International GNSS Service. Oops, it's not going. Okay. So SIRGAS is a voluntary country collaborative project focused on obtaining regional geodetic infrastructure based on IAG standards, recommendations, products, and services. The case IGS, for example. The SIRGAS goals establish and maintain a continental geocentric reference frame, define and maintain a unified vertical reference system consistent at a global level, develop and update gravimetric geoid model and continental coverage, establish and maintain a continental absolute gravity network. So in the right side, you see operational structure of SIRGAS. Besides directing and scientific councils, SIRGAS has 3 working groups connected directly to the IEG subcommissions, subcommission 1.3b for reference frames and 2.4b gravity and geoid. And they are responsible for practical and training activities in the region. To carry out the activities related to SIRGAS reference frame, in case activities from working group 1, we need GNSS data centers, which follow IGS guidelines and standards. So SIRGAS network has 1 regional data center, which is the GFI Tune here, and natural data centers that are national geodetic agencies in the region that provide GNSS data. We have 10 processing centers. 1 is IGS Regional Network Associate Analysis Center, GGFI, and 9 American institutions, national geodetic agencies or universities responsible for daily processing. For the weekly combination, we have 2 centers, GGFI and IBGE. For GNSS data processing, we use 2 softwares, Gamut GlobeK and Bernice software, and for the weekly combination, Bernice software. We have a 4th center, the SIRGAS Analysis Center for the Neutral Atmosphere, CIMA, responsible for tropospheric zenith part delays with an hour sampling rate. As mentioned before, SIRGAS network counts with a collaboration of many national agencies providing GNSS data. In this slide, we see examples of some national GNSS networks from Argentina, Uruguay, and Brazil. So the collaboration between countries build a regional infrastructure with 491 stations at the moment, including stations in US and Canada since 2001. With the establishment of a geodetic reference frame for the Americas working group under the regional committee UNGG Americas. And then we have all American continent together. For the high precision, daily and weekly network solutions, and for the accessibility to the global reference system, it is necessary to apply IGS guidelines, standards, products, and models. For example, satellite orbits, satellite in-station clock offsets, and Earth orientation parameters, as well absolute IGS antenna phase center correction model for satellite and receiver, and IGS weekly station coordinates. This means that SIRGAS daily and weekly solutions are consistently tied to a global reference frame through these products. In this case, is the actual IGS realization, IGB14, applying products in the GNSS data processing and combination. So we provide SIRGAS products, which are weekly station positions, multi-year solutions, surface deformation models, and tropospheric parameters in our interval. So the next presentations of this workshop, we will detail a bit more about computation of some other products and models in the scope of IGS activities. Regarding GNSS data processing strategy, we have in this slide the main steps and informations and models applied. At the end of daily processing, normal equations are computed by applying double difference strategy and are combined to produce loosely constrained weekly solution for station positions in SINEX format. So this slide shows the weekly combination workflow. So from these weekly loosely constrained solutions provided by each processing center, the constraints are removed, providing a free network solution here, and proceed to the outlier detection of the individual solutions, individual ones, until the final combination with two results. One, applying minimum constraint condition, no net rotation, no net translation, using a subset of IGB 14 reference stations. And the second solution is unconstrained weekly solution for IGS cumulative solution and for multi-year solutions. We do check the coordinates quality and consistency with IGS weekly coordinates and between SIRGAS combination centers. So here you can see the consistency between IGS and SIRGAS weekly solutions between weeks 2110, 2000 GPS weeks 1200, 2110 and 2174, with 1 millimeter RMS for horizontal components and 3 millimeter for vertical components. So the multi-year solutions are carried out by the GFI. They ensure the long-term stability of SIRGAS reference frame, and as a result, we have coordinates and velocities. For the multi-year solutions, this GNSS data is reprocessed in the same IGS frame, applying products from IGS reprocessing campaigns. For example, REPO1 and REPO2. In this slide, we have the last one, SIRGAS multi-year solution, aligned to IGS 14, epoch 2015, and the time span from 2011 to 2017 with 345 stations. And a new one solution must be available soon with about 700 stations and 20 years of GNSS data aligned to IGB 14 epoch 2010. This map shows the stations used for this multi-year solution. And in this solution was included some global IGS stations collocated with VLBI and SLR in order to integrate SLR solutions in this solution as well. And the computation in this solution, we have the computation of post-seismic effects. So this workflow shows the steps of this multi-year solution besides GNSS data reprocessing in the same IGS realization. The weekly combination is carried out with about the same steps mentioned before that we had for SIRGAS weekly solutions, but with outlier and discontinuity detections from the station coordinates time series. In this case, we have many years of solutions that we need to evaluate this position time series. The same as in the weekly combination, we have two results, one applying minimum constraint condition using a subset of IGB reference stations, and the second one, the unconstrained weekly solution. This weekly unconstrained solution can be considered, for example, for national realization. And here we have an example of a national multi-year solution which is 20 years of GNSS data, and as a result, it is provided to users the residual time series in north, east, and up component, where you can see discontinuities, these green bars. Discontinuities do antenna change, and for each of these periods, we provide coordinates and velocity. This is important to users of this core station, exactly how is the behavior of this station along the years. So how to collaborate with IGS products improvement? This map shows us that IGS network has not an equal station distribution. Some continents are more densified than others. And inside this red square, where we have a great part of American countries, we see some areas that need densification, mainly for multi-constellation data for GNSS products. In the graphic, we can compare the blue bars representing the number of GNSS stations per country, and the orange bar, the number of IGS stations, and we see large differences. So as final remarks, the IGS products are essential for the high precision GNSS solutions to provide, to provide the direct link to the ITRF through the IGS reference frame and ensure the consistency between these reference frames, regional and national. For example, IGS products must be applied to maintain and ensure long-term stability of a reference frame for daily, weekly combination, for daily processing, weekly combination, and multi-year solutions. I would like to call attention to the importance of open GNSS data sharing for benefit of realizing and improving the access to the global geodetic reference frame at the national, regional, and global levels, mainly for multi-constellation data, for the IGS products improvement, and for geodetic research. So thank you very much for your attention. I invite you to visit us at SIRGASEPGH.org and follow us in SIRGAS Americas. Thank you very much.
Oh, thank you, Sonia, for this nice introduction in the work of SIRGAS. I think other regional networks could make similar reports. There is a question in the chat from Renato Filia to you and Tom, possibly also to Alison. Shall I read it, or do you want to present it by your own?
Renato, material and presentation.
Does IGS plan to maintain a continuous provision of RINEX daily files? This is important support and assistance to every multi-GNSS researcher. I think this data, or it's one of the IGS products that we provide the RINEX files in databases, and I think in SIRGAS it's the same.
Yeah.
And so from this, I think this wish is fulfilled. Oh no, it's multi-GNSS navigation messages, but there's also a combined product. I think at CDS, compiled by Oliver Montenburg and his colleagues. They have RINEX navigation files with all navigation messages collected into one file.
There's also an IGS combined file.
Yeah, I
But
think
you can email the Rhinex working group or sorry, this is the Rhinex working group chair. So there are options for this. Yeah, thanks.
then I think the other questions in the chat are more general, and this I think we can take to the end. Is there something else what is direct related to Sonia
I don't see.
or Tom? And I think we are in schedule and can hand over to Arturo for the antenna calibration stuff.